In this video, we're going to continue to graph rational functions. So this is a particular example that I would like to look at. So again, my first suggestion would be to factor both the numerator and the denominator. So in this case, the numerator factors 2x plus 1 and x minus 2, and the denominator factors the 2x plus 1 and x minus 3. Now, that simplifies to x minus 2 divided by x minus 3. Okay, so for part A then, the domain, go back to the original factored form. We know that x cannot equal what? Negative a half, and x cannot equal 3. Okay. So writing that in interval notation, putting the negative a half and 3, I can shade in here, here, and here. So in interval notation would be written like this. Okay. Okay, part B is to calculate the intercepts. Well, x-intercept, I'm going to do f of x is equal to 0. Now remember, when a fraction is 0, when the numerator is 0, so that's easy. I'm going to do x minus 2 is equal to 0, and x is equal to 2. So the x-intercept is 2. I can write that as an ordered pair 2, 0. Okay, the y-intercept, we know x is 0. So I'm going to plug in f of 0, and that's going to be negative 2 divided by negative 3, which is equal to 2/3. So the ordered pair is 0, 2/3. Okay? Now, I'm going to rewrite, again, f of x is equal to, so I don't have to go back up later on. Okay? Okay. Part C is my asymptotes and wholes. Okay? So my whole, okay, we'll scroll back up quickly. Notice a common factor that divides out, so we know x equal to negative a half is a whole. Vertical asymptote is setting the denominator equal to 0, so that's x equal to 3. The horizontal asymptote, the degree of the numerator is 1, the degree of the denominator is 1, so the equation of the horizontal asymptote is y equal to 1, 1 divided by 1. The slant asymptote is none, since the degree of the numerator is equal to the degree of the denominator. Okay, now the only other thing that we need to check at this particular case, okay, does the graph cross the horizontal asymptote? Now remember, in the last example it did, so it's very important that we check this. Well, you know y is equal to f of x, and we also know the horizontal asymptote is y equal to 1. So I'm going to replace 1 for f of x. Okay. Multiply both sides by the denominator for this. So that's what? X minus 3 is equal to x minus 2. Subtract out the x's. Since 3 does not equal negative 2, this is not going to cross the horizontal asymptote. Okay, so now what I'm going to do is to go above, and we are going to start plotting our points and asymptotes that we have. Okay. All right, so first of all, let me label my axes and my slashes. All right, so we've got 0 and 2/3. And we have what? 2, 0. Okay. Now, the vertical asymptote is at x equal to 3, so I can draw that. And we have a horizontal asymptote of y equal to 1. Okay. Now, the other thing is we have a whole at negative 1/2. So again, approximately about here, that's a whole. Though it looks like a circle, that is a whole. We have the first part of this graph, because again, we know we're never going to cross the vertical asymptote, and we just worked on that it's not going to cross horizontal asymptote. Now, one other part that we need to do, is the graph going to be in this region or this region? Well, I don't know until we test a point. So to the right of 3, let's do 4. We're going to do f of 4. 4 minus 2 is 2. 4 minus 3 is 1. That's 2. So the ordered pair here is 4, 2. Okay. So we know that it is going to be above. Okay. And again, we know it's never going to cross the horizontal asymptote. And we are done with our graph here. Okay. Again, let me try to draw a hole there for -1/2. Okay. Okay, there's one other example that I would like to take a look at then. So again, the process of this is going to start, again, I'm going to factor the numerator and the denominator. So the numerator, x plus 1 times x plus 3, and the denominator, I can't factor any further. Okay? So immediately you know there's no holes because there's no common factors that are going to divide out. Okay? All right, but let's start with the domain. Okay? So what? The domain, x cannot equal -2. Okay? So in interval notation, I can write all real numbers except -2. Now, if you have a difficult time seeing that, just draw a number line, put an open circle at -2, and shade the two regions. Easy to see. Okay, intercepts. X-intercept, we know f of x is equal to 0. Now again, when is a fraction 0? When the numerator is 0. We already factored the numerator. Okay. Now that you know the factors, the zeros are easy to write also. So that's -1, 0 and -3, 0. Okay. Y-intercept, x is 0. So I'm going to go back to the original function. So f of 0, that's 3 on the top, 2 on the bottom. So we know it's 0, 3/2. Okay. Okay, so now let's talk about these holes and asymptotes. Okay, I'm going to put these here. Okay, hole, there's none since there are no common factors. Okay, make sure you can give an explanation on why there are no asymptotes or holes in the problem. Okay, vertical asymptote. Okay, so again, I'm going to rewrite this problem again so that we can see it. I'm going to put f of x is equal to x squared plus 4x plus 3 divided by x plus 2. Okay, vertical asymptotes are in the denominator, so the equation of the vertical asymptote is x equal to -2. Horizontal asymptote. Well, the degree of the numerator is larger than the degree of the denominator. Well, what does that tell me? That there is none. Okay. Okay, slant asymptote. Well, there is going to be a slant asymptote because the degree of the numerator is larger than the degree of the denominator. Okay, so again, because the denominator, the leading coefficient is 1 and the exponential power is 1, I'm going to use synthetic division for this. Okay, so it would be -2. Okay. So again, I don't care about the remainder. The slant asymptote here is y equal to x plus 2. Okay. Now, similarly to what we did with the horizontal asymptote, we want to know, does the graph cross the slant asymptote? Well, what do you know? You know y is equal to f of x, and you know the slant asymptote is y equal to x plus 2. So I'm going to replace the f of x on the original function with x plus 2. Okay. Now again, similarly to the last problem, I can multiply both sides by x plus 2. So x plus 2 times x plus 2 is x squared plus 4x plus 4, foiling or distributing. And that equals x squared plus 4x plus 3. Notice the x squared subtract out. Notice the 4x's subtract out. I'm left with 4 equal to 3. Does it make sense? So no, it does not cross the slant asymptote. That's good for us. That will be a restriction for the values for us. Okay, so I'm going to go back up then, and I'm going to start plotting what I know for sure. Okay, so I'll label these as such again. Okay. All right, so what do we have? We've got negative 1, 0. We have negative 3, 0. Okay. And we also have 0 and 3 halves. Now, let's start putting in some of the asymptotes that we have. So I'm going to scroll down a little bit just as a reminder. So we have what? X equal to negative 2. Now, the slant or oblique asymptote, I'm going to write up here again. That was y equal to x plus 2. Okay, so now I want to graph this. Well, I'm going to use a slope and a y-intercept. So 0, 2, that means up 1, right 1, up 1, right 1, up 1, right 1. So then down and left, down and left, down and left, down and left. You want enough points so I'm somewhere crossing all vertical asymptotes. Okay? So it's going to be dotted here also. Okay. Now, remember, it's not crossing the slant asymptote ever. We've already proved that algebraically, and I'm never going to cross a vertical asymptote. The good news for us is going to be this graph is pretty much done then. Okay. You've already got a point to the left of the vertical asymptote. Okay. And you've got 2 points to the right. Okay. And again, I'm not crossing either of the asymptotes. So the graph that I have in black, okay, should be it. Now, let's go to Desmos and to verify that. Okay. And this graph and our graph look very, very similar.